All right, here's the graph you should have gotten. What's happening is it's going to a horizontal asymptote of 0 and a horizontal asymptote of 0. And then it starts at, there's ways of labeling the or the y-axis in the way that will make sense, but this is pi over 2. So what I'm trying to say is there's a way to label the y-axis on Desmos so that it labels it with radian increments, basically. But you don't have to worry about that. I'll just tell you that this graph goes from pi over 2 to negative pi over 2. And then as x becomes bigger and bigger and bigger, what's happening is we're going to 0. So remember what cosecant is. Cosecant is the ratio of the hypotenuse to the opposite. So if this input x is the ratio of the hypotenuse to the opposite. So what's happening is the hypotenuse is becoming much smaller. Wait, one sec. Sorry, the hypotenuse is becoming much bigger than the opposite because x is becoming bigger and bigger and bigger and bigger and bigger and bigger. That was a really good trace, almost. Okay, so x is becoming bigger and bigger and bigger and bigger. So as x becomes bigger, then the hypotenuse must be much bigger than the opposite. So in a triangle, what that looks like is it looks like this. The hypotenuse, try a little better, hypotenuse, and then opposite. So we're looking at this side, and then we're looking at the hypotenuse. Well, what we see is the angle, the reference angle, theta, is getting smaller. And remember that the output of an inverse trig function is an angle. So the output of this function is an angle. So what's happening is the angle is getting smaller and smaller and smaller and smaller. If we draw another picture, where this time the hypotenuse is even bigger compared to the opposite. Okay, again, really hard to draw triangles like this that are super big. But the point is, it's so hard because this angle is becoming really, really small, which makes it a hard triangle to draw. But as the hypotenuse becomes so much bigger than the opposite, what's happening is the angle is getting smaller and smaller and smaller. And that's happening on both sides of our graph. And then as we approach this value of 1 right here, okay, we can see that we're right at our tick mark of 1. Well, that would be where the hypotenuse and the opposite are exactly the same. Okay, the hypotenuse and the opposite are exactly the same. We have a straight line. So we're approaching a triangle that is essentially a straight line. So we'll start with one we can see. So now again, we're looking at the opposite side, and we're looking at the hypotenuse. They're becoming closer and closer together because x is getting closer to 1. So the ratio of the hypotenuse to the opposite is getting closer to 1. Well, what's happening to the angle? It's getting closer to 90 degrees, which as a radian is pi over 2. So as x gets closer and closer to 1, the output, the angle, is going to get closer to pi over 2, which is why our graph just stops at pi over 2. Because at that point, our angle can't get any bigger. It's just a straight line. At that point, it's just a straight line. And then what's going to start happening is we're going to start getting our negative angle. So then we'll go to negative 90, and then we'll shoot to 0 from the negative side. All right? So that's why the graph of arc cosecant makes sense. It's just about these triangles, and what happens to these triangles is the ratio of the hypotenuse to the opposite becomes bigger, and then when that ratio becomes closer to 1, what's going to happen to the overall angle? Well, as it gets bigger, the angle is going to go to 0, and then as the ratio gets closer to 1, the angle is going to go to 90, which is just pi over 2.